Well, you could just think of them as biophysical operations that are key to the behavior of the brain, such as synaptic interaction, nonlinear synaptic interaction, such as generation of action potentials, such as delay operations.
But the generation of action potential involves organization of proteins, and that proteins rely on quantum effects.
Yes, except there's no evidence for any macroscopic quantum states that are entangled over the time scales and the spatial scales that are relevant to the brain.
I agree with that, but that does not mean that quantum mechanics is irrelevant to the brain.
I didn't say irrelevant. I said there are no macroscopic quantum entanglement that are relevant, that seem to be relevant to the behavior. Plus, it's a prediction. I mean, I may be wrong. I just don't see anywhere in the brain.
Okay.
Like you, I strongly doubt that there's any quantum information processing happening in the brain. On the other hand, the logic that you're using for dismissing it to me seems completely backwards, because you say that you point out all the things that neurons do in the brain, and you say that that they can't do the kind of operations that quantum things allow you to do. The Shor factoring and Grover search and so forth. But isn't that the whole point? That if you did use it, you wouldn't use it to do what the neurons can already do. You would use it to do what the neurons can't do. So the fact that it doesn't do that the neurons can't do that kind of operation seems to me irrelevant.
Okay, but on the other hand, we're beginning to have theories, for example, of vision that seem to capture a lot of aspects of vision, where we can now, for example, Tommaso Poggi's work at MIT, who has shown that you can now replicate, or you can begin to replicate behavior in real images of real subjects with simple neural network architecture without need of any fancy stuff. You just have the linear, the usual linear, nonlinear operation with some learning thrown in there. So I just don't see any need, never mind the physics, just computationally, I just don't see any need for calling on quantum mechanics to do things that we think the brain can do. Again, we may be wrong.
Hi. With the after-image experiment, you're able to show that the conscious perception happens at a higher level somewhere. But with the consciously perceiving Jennifer Aniston, can we say anything about where that is in relation to the hippocampal cell that recognizes her?
Yeah, it's probably before. So as I said, I don't think these are the neural structures that are responsible, the one we record from, for the conscious perception of Jennifer Aniston. That probably happens in fusiform gyrus, and there are almost no seizures in that part of, essentially in the back part of the brain, there are no seizures, which means you have no business being there with your microelectrode. And so we don't record from that. These are the structures where the patient remembers. So in fact, this patient actually worked with, she worked in Hollywood, so she worked with her, and she'd seen her on a daily basis. So probably what happened, she remembered, oh, that's Jennifer Aniston, and that was what we actually saw. That's probably the correlate of, that's also why the delay is so so long. It's 300 milliseconds, which is inordinate long if it were a purely visual thing. So I think what we're seeing here is not, it's more the access into the memory, what we're observing, not the visual percept.
Very exciting. In the last slide, you mentioned one theory of consciousness, which is Edelman and Tonone. And if you can elaborate a little bit of what you would like to see in a theory of consciousness, or what kind of theory of consciousness would be helpful for understanding or for experiments?
Well, I mean, ultimately a reductionist theory that explains you see, people always say, well, there isn't a lot of facts about consciousness, but you can write a textbook of everything we know about consciousness and how it interferes and what goes on in patients and in animals and prosopagnosia and cataconia and all these states. So you want a theory that ultimately explains all of those things, and that fundamentally explains, I mean, the central dilemma. And I think, well, I mean, I should really let Jerry talk about it. That explains why that certain physical system of a certain type have these very rich states that are both integrated as well as highly differentiated. And I think, for my money, this is the most promising theory we have right now. And it's independent of the hardware. So it says, at some point the internet could also become conscious. So it's not just a theory like a dual aspect theory like David Sharma. So in his appendix of his PhD thesis, he's very sympathetic toward dual aspect theories of consciousness. In other words, where you say, well, there's the objective aspect of reality, of information you can measure in Shannon, but then there's the subjective. But he doesn't specify what sort of architecture. It has a light switch. He would say this also has consciousness, right? Now that's not very appealing. I want something that's a little bit more quantitative that tells me, well, why is this remote microphone amplifier? Is it conscious or why is it not conscious? And how could I test it? So you want a theory like that. And I think for my money, it's the most promising approach we have.
You mean, if I understand, maybe I should ask that later in the panel, but so they provide some very nice explanation in graph theory terms of the integration about the different. So according to such a theory, every model or every graph that has this structure will be conscious?
What? Yes, I think so. Yes.
You mentioned that you had become a vegetarian, but aren't there some theories that say that even plants might have a consciousness? Might be conscious?
Well, there was actually this interesting debate in the 19th century about, you can read it, about whether. For instance, what they did at the time, they took a frog and decapitated it, and the frog can still jump. And you can put a little acid on its left side. This is a decapitated, or you do on the left side and it'll scratch off. It won't just generalize, it'll do specific. And if you raise on a farm, you cut off a chicken head, the chicken can run around, right? like a headless chicken, right? But then people concluded, well, by and large, the behavior is too simple, it's too stereotypical, there doesn't seem to be any consciousness. Now, I can't rule it out, my spinal cord is conscious, but there doesn't seem to be any evidence for it. So rather than endless speculation, there has to be sufficient complex behavior. So, forget about plants, and even sort of simple, single-cell organisms, if they just do very stereotypical things, right now, I see no reason to them. This may be wrong ultimately, but I think right now index for consciousness, reasonable, complex, non-stereotypical behavior that involves online dynamic storage of information. All right.
Okie doke. Well, I think it's time to move on to the next part. Thanks, Christof. And the floor back. So I guess we're going to just move on to the panel discussion. Okay.